What's going on, everybody? We're going to start today with the fourth video in the oral prep series for the 767. The third video is going to take the center portion here of the overhead panel, so it's starting here at cargo heat, going down through the rat, the engine start selectors, the fuel panel, and the fuel indicators, down into the anti-ice system. Probably won't take quite as long as the others. I don't know. We'll see. I always say that, and it always ends up going a hell of a lot longer than I want it to. All right. So if you haven't watched the first three videos, I'll put a thing up here, a card or whatever it's called, up above my head. That'll have the actual playlist. Go back and check out the other videos to kind of give you an idea of how we got to where we are. First thing I want to say going into this, the top portion right here, cargo heat, these have to be, I don't say have to be, they are pretty useless. These three switches are relatively useless. And I say that simply because this is a self-contained system. It does everything automatically. It does everything on its own. And if you don't believe me and you work for somebody who flies a 7.6, check your QRH for these things coming overheated. And just, I don't know, if you have anything other than what I'm saying, go ahead and tell me different. But what you're going to end up seeing is there's going to be two options. So the overheat light's going to come on. You're going to look up the overheat light in the QRH, and it's going to say, is it required? Is cargo heat required? And then that's going to be the end of the checklist, because if it's required, it basically wants you to keep it turned on. And if it's not required, turn it off. It's that easy. So there's not really a lot to ask on these particular switches. Down below that, we've got EMER lights. So, okay, cargo airplanes have these, passenger carriers have these. These are your emergency lights, the things that say exit, and then could be some lighting in the back, things like that. So notice there's a light here next to it. This light says unarmed. Okay, so that's if let's take this. Oh, and we'll move it into the... Why is it not letting me do it? Hang on. Maybe you got to unpause it. Come on. Let me move the switch. I just want to move the switch. Maybe I'm not at the right angle. At any rate, when this switch is in any other position other than the arm position, meaning if it's off or if it's on, it is unarmed. So you will see this light that'll come on. It'll say unarmed. That tells you that it's either in the off or the on position. The armed position is what it goes to when it's closed underneath that guard. And then we've got this. Passenger carrying airplanes, this is what it'll look like. It'll say passenger oxy, and it'll be guarded just like it is here, because we don't want to accidentally hit this switch. Because what does it do on a passenger airplane? Right, it drops the rubber jungle in the back. So we don't want that to happen. On a cargo carrying aircraft, we don't have a rubber jungle. There is no oxygen masks in the back of the airplane for the passengers. So this switch is open like that, and it is to check the secondary crew oxygen bottle. That's what it's for. If it's installed. Hell, it may not even be installed depending on the type of airplane that you're on. So passenger airplanes, that's a bad switch to hit. Like to call that the resume switch, because if you hit it, you're grounded wherever you are, and generally you may be updating your resume. Who knows? But on a passenger or cargo carrying aircraft, you can that's just checking your secondary oxygen bottle. Okay, now below that, engine limiter, you can see that's been removed. The 7.6 doesn't have the engine limiter. But we do have a ram air turbine, or a RAT, or a ram air turbine, depending on where you're from. This is what's going to come out anytime we have what? What has to happen for the RAT to automatically deploy while I'm in flight? Dual engine failure, good. So dual engine failure means that both engines drop below 50% N2. When that occurs, the rat will drop out to be able to give us hydraulic pressure to the center hydraulic system that allows us to have some primary flight controls. That's what that is for. I know if you're watching this and you came from, I think it's the ERJ, maybe even the CRJ, the rat on those airplanes give electrics, I believe, or maybe it's electrics and hydraulics, one of the two. But on the 7.6, it is strictly just a hydraulic thing. That's all it's for. And it's for the center hydraulic system. And it's to be able to give us primary flight controls on the center hydraulic system to allow us to fly the airplane during a dual engine failure. Now, that is for automatic deployment. What about manual deployment? Am I able to manually deploy this thing? Yeah, sure. That's why I have a switch, right? So I open up the switch, I open up the guard, press the switch, boom, the rat comes down. Okay? Couple things with that. I don't want to do it because if somebody's walking around the bottom of the airplane and while I'm on the ground and I hit that switch, it will come out of the bottom of the aircraft. It comes out just behind the right wing and it comes out with some force. So if anybody's standing underneath it, it could potentially hurt them, severely in some cases. The other thing is I can't reset it from the flight deck. I have to have maintenance come out and reset it. So if I accidentally hit it, now I look like an idiot because maintenance has to come out and, put it back up and lock it back into place. So both of those don't sound like a good option. So what are the requirements that I have to have for the rat to actually work? Okay, so the first thing we talked about, dual engine failure, right? So dual engine failure. I have to be off the ground, meaning my trucks need to be tilted. My main gear trucks have to be tilted. And then the third thing is I have to be going faster than 80 knots airspeed, which hopefully if you're in flight, you're going faster than 80 knots. Now, those are the three requirements for the automatic deployment. What about for it to actually work? Like for it to give me the amount of pressure I need to be able to actually have some center hydraulic pressure to my flight controls. Any guesses? 130 knots. So I need to be at a minimum of 130 knots to be able to get the amount of airflow I need to be able to get the pressure from this system. Now, the funny thing is, I'm not going to hit it. I will show down here the light test thing. Notice it has a pressure light and it has an unlock light. Things that are green are generally good, right? But when has a pressure light ever been good? Well, in this case it is, because this is telling me that I have enough pressure that I'm going to have some sort of flight controls from the center system, from the center hydraulic system. Unlocked, that just tells me that it unlocked. Now, if I have dual engine failure, it's going to do it on its own, and the unlock light will illuminate, and it'll tell me, sweet, it's unlocked. But I'm going to run the QRH anyway, and the QRH is still going to have me push that switch just in case it didn't come out. Okay. All right. So 130 knots to get the green pressure light to get pressure to my center hydraulic flight controls. Over 80 knots, truck's tilted, meaning I'm off the ground, and both engines below 50% into for automatic deployment. Okay. Manual deployment can still be done by the switch while I'm on the ground. And remember, it can be done at any time because that's connected to which battery bus? The hot one. So it's connected to the hot battery bus. So if I would push this switch at any given time, that rat's going to pop out on the back side of the airplane. Okay, so now we can move down here to our engine start controls, our engine control, our starter control panel, whatever you want to call it. There we go. Lights went out. So we've got valve lights, which you saw here. The valve lights are what kind of lights? Disagreement lights, right? So they're in a disagreement, meaning the valve was supposed to be closed and it's open, or the valve is open and it should have been closed. Yes. There you go. So if that light is illuminated and it stays illuminated, you're going to want to run a checklist, because that's not something you want the engine operating at high into RPMs with that light being on, because you can cause damage to the starter in that particular case. All right, here in the middle, these are our igniter selectors. So each engine has two igniters. Okay, like this. You got one on this side, one on this side, and they fire whenever they're told to. If I have one, it might be, I don't know which one's which, but it'll be like, let's say the left one. And then if I have two selected, it'll be the right one. If I have both selected, then both will fire. Now, depending on your airline will depend on how you do this. The airlines I've worked for, odd days, meaning like the 21st, 23rd, 25th, would be on one. Even days, 22nd, 24th, 26th, would be on number two. I've also heard where it's been captain's leg versus FO's leg. So captain's leg would be one, FO's leg would be two. It doesn't, I don't care how you do it. It doesn't matter how you do it, as long as you're switching each time you start the engines. And what that does is that limits the amount of duty cycles on those igniters, and it lengthens the life of them. If you are in both all of the time, or if you run one igniter all of the time, you don't know if you run one igniter all of the time. So if I would constantly be in the number one igniter, I wouldn't actually know if the number two igniter was going to work. I just wouldn't. And if I run both igniters all the time, now I'm just giving unnecessary duty cycles to those igniters, and I can burn them out early, costing money for me to replace them. Okay? Now, some airplanes don't have a 1, 2, and both. They have a single, dual, or single and both. In those particular cases, if you keep it in the single, it will automatically switch between the 1 and 2 igniter. It won't stay on the same igniter. It'll automatically switch between them during each engine start or subsequent engine start. So that's kind of good. It keeps track of the shit for you, which is nice. All right, now we come down here to these, our ignition switches, or our starter switches. The off position, that's an easy one. I'm not going to insult your intelligence. That just means they're off. Continuous means it's firing continuously with whatever one I have selected. So if I have one selected, it fires continuously. If I have two selected, it fires continuously. If I have both selected, it fires continuously. If I go into the flight position is going to fire both igniters regardless of what I have selected. And this is going to be when we have our dual engine failure. So if you think about your memory items, most of the time, memory items include a dual engine failure. And in that case, it's, both igniter switches to flight or engine start. Oh, God, see, now I got to look at it. Engine ignition switches or wherever it is, both to flight. So you go to flight. And hopefully, maybe it was a bad igniter. Now both of them start firing. Maybe the engine will, kick back on. All right. So now we go into auto. So when we go into the auto position, there's going to be two reasons why the igniters will fire. Any guesses as to what it would be? Good. It'd be engine anti-ice, or EAI, or TAI, thermal anti-ice. So whenever we turn on the engine anti-ice, the igniters automatically turn on and start to fire, because it figures you're turning on the anti-ice because it's cold, and the last thing you want when it's cold is your engine to quit on you because you don't have a spark. So turn on the engine anti-ice, they start firing automatically. The second one is flaps extended. So anytime the flaps are out of the up position, your ignition is firing. And that happens because, again, you're low to the ground, you're slow. That's the last place you want an engine to go out on you is on approach, right? And then, obviously, if I'm taking off and I'm at high power settings, I really don't want the engine to quit on me because I have a loss of ignition. Because, well, high power settings mean, V1 cuts and just nastiness with one engine stuff. We don't want that, right? So it automatically fires your ignition. Now, the ground position. There's a video that I have that I talk about the ground position. I talk about what it does. I put the acronym on the screen. I'm not going to do that here, so you can just write it down as I say it if you really want to take notes and that kind of stuff, which I encourage you to do if that's why you're watching these videos. First off, ground. It does 4 things primarily that I care about. It does the acronym SAIL, S-A-I-L, okay? That is starter valve open. So it opens your starter valve, allows air to go into the engine to be able to turn the starter because the starter is a pneumatic starter. So opens the start valve. It forces the APU to go into a high flow mode, okay? Basically, it ramps it up and causes it to create more air, more pressure to go into the engine to be able to turn it. It also opens the APU bleed valve if it wasn't already open. Then we have I. I is going to be ignition armed. It arms your ignition. Now, why does it arm the ignition? We don't want to start firing those things until fuel is introduced. Fuel doesn't get introduced until max motoring or basically 20% into or max motoring, which is any time that you don't progress more than 1% in 5 seconds. Then you add fuel, it fires off, and away it goes. Okay. The ignition is armed to fire the moment that fuel control switch is moved into the run position. And then the last thing is L. And then if you remember when we talk about electrics, when we talked about the utility buses and what happens during engine start and how those utility buses shed during engine start, that's what the L stands for. It's load shed of electrics. Okay. Now, I grew up Southern Ohio. I'm a hillbilly. I got some redneck sounding to me. You can kind of tell I have a little bit of an accent. I used to be a lot worse before I joined the military. So if you want to be lazy with it, like I am sometimes, you can just say electrics. You can load shed electrics. That's what the L stands for in that particular thing. But that's the acronym, SAIL. Okay, so start valve, APU in the high flow, APU bleed valve open, ignition armed, load shed of electrics. Okay, that's what that does when you go into the ground position. Now, at what point does it go from the ground position back to auto? Well, 50% N2. And if that number doesn't sound familiar to you by now, it should. 50% N2 is what happens with a lot of things. That's the indication on that particular card that dictates whether or not the engine's running. It's also when everything kind of the load sheds and everything go away is when 50% N2 occurs. When 50% N2 happens, the load sheds go away for things like your hydraulic pumps, your utility buses, your fuel, which we'll talk about here in just a second because we haven't gotten there yet. But all of that happens at 50% N2. So that should be a number. That 50% N2 should be a number that you have ingrained in your head when it comes to the 7.6. Now, if you're one of those guys that fly the 7.5 and the 7.6, when I get done with the oral portions of the 7.6, I am going to do a series on the 7.5, and then I'm going to do a differences between the two. And we'll talk about the differences in the engines on the 7.5 and the 7.6 and some of the numbers that are different. Okay, so now we get down here. We're on the fuel control panel. Or really the fuel panel. I came from an airplane. So my original airplane, if you don't know, the original airplane I came from was a KC-135 R model. 10 fuel tanks. Pretty much can move fuel from any tank to any other tank. You could pump it, from tank to tank. You could gravity feed it. You could use it to refuel airplanes in flight. You could do all kinds of stuff with the fuel on the aircraft. So that was a very complicated fuel panel. I get to this one. This one has got to be one of the easiest fuel panels that you could ever mess with. So let's take a look at what's going on here. So I've got none of my pumps are on. None of my fuel pumps are on. Now remember, I've got it paused, so it's it won't really do what I want it to. So I'm going to unpause it for a sec. So notice I turn the pump on. Pressure lights go away. I turn the pumps off. Yeah, I get cautions, warnings that tell me, hey, you've lost fuel pressure. Fine, I know that's going to happen. But my pressure lights illuminate. Now, look at my center pumps. Turn them on, I get pressure lights. Turn them off, nothing. So why do you think that happens? Okay, so first off, the center pumps do not run unless the engines are running. So the right center pump doesn't run until the right engine is above 50% into. The left pump doesn't run until the left engine is above 50% into. So that is why when I turn them on, you'll see a pressure light illuminate, because I'm telling it to run. It's not running. Therefore, I don't have any pressure, so low pressure light comes on. But why isn't the pressure light there when I turn it off? Okay, so the reason that pressure light does not illuminate when I turn the center pumps off is because it is a normal condition for the center tank pumps to be off. That's why. It's normal. Because if we think about how we burn fuel in the 7.6, so the first thing we do is we burn center tank fuel first. We empty the center tank. And then after we empty the center tank, we turn the pumps off after we get the pressure lights and we get low pressure messages and that kind of stuff that kick on, right? So turning it off would be a normal condition. And the way Boeing looks at it is they don't want you to have indications for something wrong when it's normal. Same thing goes for the demand pumps in the hydraulic system. So with the center tank pumps off, the pressure lights are extinguished because they are inhibited to be on or illuminated, because it's a normal condition for those pumps to be off. But one thing you will see is its fuel config light come on when there is fuel in the center tank and these pumps are not on. So if the center tank pumps aren't on and there's more than how much fuel in the center tank, 1,200 pounds, and there's more than 1,200 pounds of fuel in the center tank with these pumps off, this light will illuminate, telling you that there is something set incorrectly on the fuel panel. Okay, so now let's play a different scenario. Let's go ahead and we'll do this. We'll turn all of our pumps on, like so. And we'll pretend that my engines are running and the pressure lights are extinguished. Okay, so all the lights are extinguished. So we're off flying. And when we're off flying and I've got my fuel panel set up like this, which fuel pumps are actually feeding my engines at this point? The center pumps, right? So the center tank pumps are the ones feeding my engines. So why do the center tank pumps feed the engines when I have all the pumps on? It has to do with pressure. Okay, my center tank pumps are approximately double the pressure of my mains. So even though numbers don't really matter, we can talk about what the numbers actually are in the maintenance manual and stuff like that. But it's if we use approximations, 15 pounds of pressure on the main tank pumps, 30 pounds of pressure for the center tank pumps. It might vary a little bit one direction or the other, but it's approximately double of what the main tank pumps are. So what ends up happening is when the center tank pumps run out of fuel because the center tank's empty, these will automatically take over and start to feed the engines, right? All right. So questions that might come up on an oral: which pump feeds the APU when the APU is requesting fuel? So if I come out here and I'm running the APU and I have all of my switches off like this, which pump will run the APU? Okay, so hopefully you've answered that. Wait just a second and I'll show you which one it is, right? So let's unpause. Let's come down here and we'll go to the APU. So I'm going to come down here just far enough to where you can't see that. and we're going to start the APU. We're going to go to start, go to on. We'll see our lights flash. Boom, the APU is now running. All right, so remember the answer you just said a couple seconds ago when I asked you which pump it was, right? Pause it. Did you guess the left forward? Because if you did, you're right. It's the left forward pump. It's this one right here. Now, how do I know it's the left forward? By doing that. Notice the pressure light's extinguished. Regardless of whether or not the pump is turned on by that switch, it will run to provide fuel to the APU as long as AC power is provided to the aircraft. So if the APU is requesting fuel and there's AC power on the airplane, given in this case by a ground power cart, the forward left pump will run for the APU. And it will not matter what I do to this switch, it won't stop providing fuel. So that's why that pressure light will extinguish. Okay. Really, there's not a whole hell of a lot that they can ask about this other than, but for example, like that, how do I crossfeed? That could be another one. How do I crossfeed? So now we can look here. My left side is at 12.5. My right side's at 14.8. Okay. So how do I make the left side match my right side? Well, I have to burn the high side. So what would end up happening is I would turn off my left pumps to be able to burn out of the right side, right? That's all I should have to do. Oh, no, I'm sorry. There's a step I missed, right? So I always look at it as you got to do something smart before you do something dumb. So in this case, the something smart is making sure the fuel is going to make it to the side that I'm turning off. So in this case, we'll say I've got my right side pumps running, and we'll say I've got my left side pumps running. And this is how the panel would be set up under normal circumstances. Now I want to make my system equal. So open up my cross feeds. That's to do something smart. Turn off my left side pumps, which is do something dumb. Now my right side is providing fuel to the left side. So, and not to the left tank, mind you, to the left engine. I can't go tank to tank. I can only go tank to engine. So I can go left tank, right engine, left tank, left engine, right tank, right engine, right, left engine, so on and so forth. You get the idea. So that's how I would crossfeed. Now, how do I stop crossfeeding? Or what would happen if I don't do that? What would happen if I don't open the fuel crossfeed first? So let's say I'm in a situation where I'm like this. And then I turn these off. And then I go to open my crossfeed. There is a potential that depending on how the aircraft is operating, the turns or climbs or whatever you might be doing, however you might be maneuvering the airplane, there is a potential you could flame out the engine by turning off those pumps first before opening the fuel crossfeed. And how do I know that? It's happened. It's happened. And then the pilot tried to say that he wasn't taught how to do it in training, but that's completely beside the point. But turn those pumps off before opening the crossfeed, you're going to starve the engine of fuel. Now, in theory, if you're flying straight and level and you're not in a bank or anything like that, and you're not doing any crazy climbs or descents or anything like that, then sure, the aircraft should be able to suction feed. That engine should suction feed until the tank is empty, technically. But I wouldn't want to rely on that, right? Because I know that engine can flame out by turning off those pumps. So always, always, always follow your supplemental procedures in your FCOM, first off. Second, open the fuel crossfeed before you turn anything off. Make sure that whatever engine you're trying to balance out, whatever tank you're trying to balance out, make sure that engine is getting fuel before you turn the pumps off. Okay? Now, if I was going to the other side, it would be obviously the exact opposite, right? I would go dink, 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 dink. I would do that. And then, now I'm burning from the left side to the right side. And then whenever I am done crossfeeding, I just turn on the pumps first. That's my do something smart. And then close my crossfeed, which would be the something dumb in that case, right? Okay, so now that we've talked about cross feeding, we've talked about the center pumps, when they turn on, when they turn off, things like that. I got that fuel config light. It'll also give me a fuel config message down here. If I want to go through fuel config right there. Now, obviously, I've got a bunch of messages on my iCast because the engines aren't on, so it throws a bunch of stuff on here. But that fuel config is when this light illuminates, I'll get a fuel config message. Or I could get a low fuel message. We'll talk about that too. So, I already said what one reason was for that fuel config light. It was the center tank pumps being turned off with more than 1,200 pounds in the center tank. So that will cause that fuel config light to illuminate. There are two more reasons that that light will illuminate and that message will come on. First is going to be an imbalance of fuel. So if we look at our panel here, I'm at 12.5 on this side, 14.8 on this side. That is a 2,300 pound difference between the two. The range for the imbalance is 2,000 plus or minus 500 pound. So the reason we say that it's 2,000 plus or minus 500 is because usually there's a chart, and in that chart says at this altitude, at this gross weight, blah, 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 you have 1,500 pounds of an imbalance that you're allowed to have. As the aircraft starts to get lighter, you can have more and more imbalance and it'd be okay. All right. In theory, this is not a controllability issue. In theory, this is supposed to be a structural issue on the ground for taxi. Or just the aircraft sitting with, a lot of weight on one side versus the other. You can put damage, obviously, on parts of the aircraft that wouldn't normally have damage if it was balanced. So, you could technically, don't try this, for God's sake, don't try it. But you could go completely empty in one tank and completely full in the other tank and still be able to fly the airplane, in theory. But again, not really something I'd want to test. I don't want to be that kind of test pilot. I don't know if you do or not. So that's, that's just what it is. So 2,000 plus or minus 500, that'll give you your fuel config. Now, with that being said, the last reason doesn't give me a fuel config message. It only gives me the fuel config light. The message actually is low fuel, which is not good. So low fuel would be 2,200 pounds, less than 2,200 pounds in either main tank. And if we think about how much fuel these things burn, they burn, roughly 8 to 10,000 pounds per hour. 2,200 pounds, it's not even an hour's worth of fuel. So not really something we'd want to do if we can help it. So if we look at it that way, low fuel, less than 2,200 pounds in either main tank, more than 1,200 pounds of fuel in the center with the center pumps off, and an imbalance of 2,000 plus or minus 500 will give us that fuel config light, fuel config message, or low fuel message. Okay, so coming down here, we have our fuel indicator panel, fuel quantity panel. So total quantity, where does that come from? I really hope you didn't just say add those three up and that'll give it to you, because that's not quite right. I'm very big on very specific answers. So like, for example, on the external power, whenever the avail light is on, it is good quality power, right? So good quality power. It's those three words I really like to hear. It's the same thing with the total quantity. It is a separate fuel calculation done by the fuel quantity processor. So it's 2-3 words, sentences that I like to see here when it comes to the total quantity. So it is a separate fuel calculation given to you by the fuel quantity processor. Basically what happens, it takes information in from the probes and it goes into this processor. The processor then takes into consideration the density of the fuel, altitude, barometric pressure, temperature, all this other stuff that comes off of, air data computers and everything else that we have on the airplane. And it does very smart calculations that more than what we can, and it gives you your total quantity. So there may be some discrepancies between, just adding the 3 up and then your total quantity, but they should be relatively close. So separate fuel calculation from the fuel quantity processor are those 3 things. Now, there on the left-hand side, the fuel temp. First off, where's the fuel temperature taken from on the 7.6? I hope you said the left wing. I hope. Fuel temperature is taken from the left wing because there are less hydraulic coolers in the left wing than what there are in the right wing. So what does that mean? We have 3 hydraulic systems. We have 3 hydraulic coolers. Or heat exchangers. There's 3 heat exchangers. So 1 for the left, 1 for the center, 1 for the right. On the 7.6, in the left wing, it's the heat exchanger for the left hydraulic system. The right wing has the center and the right heat exchangers for the right, center, and right hydraulic systems. So there's 2 on that side versus 1 on that side. So the theory is that the right wing would be warmer because there's an additional heat exchanger that the hydraulics coming through. So it would be a warmer tank. Therefore, the coldest temperature would be out of the left wing. So what does that mean? Nothing really. Unless we're talking about extreme low temperatures. So, generally, your QRH should have a chart. I would hope your FCOM might have the chart. I'm not entirely sure. Maybe you don't have a chart at all. Maybe you just have something in your limitations that tells you what the number is. So the minimum limitation for fuel temperature is what? It's going to be based on the fuel you're using, right? So, yeah, I don't know them off the top of my head because, again, I have a chart that I can look at. So the most correct answer is you need to be 3 degrees above the freezing point of the fuel being used. Because if you're using JP5 or JP4 or JP8 or TS1 or Jet A or Jet A1, they all have a different freezing point. So you want to be 3 degrees above that freezing point. But let's say I get close to that freezing point. What can I do? What can I do as a pilot sitting in the cockpit or flight deck? What can I do to say, I do this and it'll warm up my fuel? I can speed up. That's one. A lot of people don't think about that, but if you think about what happens when you speed up, you get friction, right? You get more air friction across the wing, so on and so forth. So therefore, it may warm up your fuel. It talks about how much Mach. It's like 0.01 Mach for 0.1 degree or something like that. But again, that should be written in your QRH or in your non-normals for fuel temperature. Second thing, really easy. Descend. We all know, there's the adiabatic lapse rate that you should have. That's a normal lapse rate of 2 degrees C per 1,000 feet, roughly. So, by dropping down 1,000 feet, you should, in theory, gain 2 degrees. But again, you continue to go farther down, you get warmer and warmer. So just descend. That'd be the easiest way, probably, to be able to warm up your fuel. Now, talk about how cold the fuel could be. How about how warm the fuel can be? How warm can that fuel go? Now, some of you may not have been lucky enough to go to places where you get extreme temperatures in the hot side of things. I've been on airplanes where when you get on them, the temperature gauge that maxes at 50 degrees C was maxed out, and it was trying to break it. It was trying to keep going. That was not fun. I don't like being in places that are 120, 130 degrees. But in those particular cases, that's where you can run into high fuel temperatures. So what is our max fuel temperature? 49 degrees. 49 degrees Fahrenheit or Celsius. Fahrenheit, Jesus. That'd be something, wouldn't it? Couldn't get above, couldn't get somewhere where it was 50 degrees Fahrenheit. 49 degrees Celsius. If you want to do the math for that, it's you multiply by 1.8, I believe, and add 32 to it. So I don't know, for a WAG, you can multiply by 2. 49 times 2, that's 98 degrees. Plus 32, it's 120, 130 degrees, whatever, somewhere in there, 128 degrees. And then you minus a couple, so I don't know, 125-ish, 120 to 130 degrees. Either way, it's somewhere I wouldn't want to be. It'd be too damn hot for me. But that's your max temperature in C's, 49 degrees. And that's a limitation. Check your limitation section to verify I'm correct. If I'm not correct, then please let me know. It's basically been that way for 3 different airlines now, so I think that's a standard for the 767. Some places, they put in some minimum limitations that are a little bit different. Like they put in, minus 45, because it tends to cover most of all the fuel that they use. All right, last thing, we're going to be down here at the anti-ice. There is not a lot really to talk about this. When would I use anti-ice? Whether it be on the engine or on the wing. There's only a couple things, right? Most of the time, your FCOM is going to have a list of what they consider to be icing conditions. That's usually going to be anything less than 10 degrees C, less than 10 degrees C with visible moisture. So if we're talking about in flight, we're talking about clouds. On the ground, we're talking about fog, rain, snow, whatever. That would be visible moisture. So we would want to turn it on for those kind of things. Now, the engine anti-ice can be used on the ground, so I can turn it on. Obviously, right now is not a good idea to do it because I've got the airplane sitting in Miami and it's warm, so I can cause damage to the actual anti-ice system if I turn it on when it's too hot. But you're going to turn it. You can turn it on and have it on the ground. Wing anti-ice, on the other hand, I can turn on. I'm going to get these valve lights because it's a disagreement because it's inhibited on the ground. Inhibited, not prohibited, meaning that it will not turn on the ground. I can hit the switch, turn it on, valve lights come on, and in the moment I take off and my trucks tilt, it says it's in flight mode. The valve lights go away and the wing anti-ice works. Most of the time, from guys that I talk to that have so much experience in this airplane, thousands and thousands of hours, they've turned on the wing anti-ice only a couple times. It's just not something that gets used. The aircraft was designed very well to shed ice off of the wings. Now the other question is, what gets anti-iced on the wing? What part of the wing gets anti-iced? So if you remember, on the wing, it's only got, it's got slats on the front and then, trailing edge flaps on the back. So what part would we want to anti-ice? Well, it's the outboard 3 slats. The outboard 3 slats have holes in them. So when you do your walk around, you go underneath the wing, you see the holes on those outboard 3 slats. That's an exit part for the anti-ice. So you can look, outboard 3 slats, those are the ones that are going to be anti-iced. On the engine, it's the nacelle. It comes out around the nacelle and warms up the engine that way. There's really not much else for the anti-ice system. Depending on your airplane, depending on, who built it, whatever, you may have this icing light that shows up here. That icing light is there's an icing detector. I believe I can't remember where it's installed. I think it might be in the TAT, but it vibrates. And if ice builds up on it, it'll change the vibration, and it changes the frequency of the vibration. And by changing that frequency, it says, oh, you've got ice buildup because the frequency changed. Not all airplanes have them installed. If you have it installed, you obviously have a QRH to follow, given that icing light. If it's not installed, you don't have to worry about it. You just turn on your stuff whenever your book tells you to turn it on. And that's it. That's all we got for the center portion here. This is video 4 for the oral prep series for the 767. We got 2 more to go. I got 1 for this side here and then 1 for this one over here. And then, of course, the 7th video will be all of these put together, which it'll be a ridiculously long video. So I may or may not do that. We'll see. If you have any questions, anything over the fuel panel, anything over stuff that I've already discussed in previous videos, please reach out to me. Again, info@gsiguybrandon.com, Brandon at gsiguybrandon.com, even training at gsiguybrandon.com. Any of those will make its way to me. You can also reach out in the comments. You can leave a comment. Let me know a question you might have there. I can try and answer it as best as I can. Or hell, maybe I'll make a short video like I just did for somebody else to be able to answer the question. Outside of that, as always, I appreciate you guys. I love that I've gained what I've gained over the last month as far as subscribers are concerned, and the amount of people watching these videos and the amount of people that have reached out to me and said that they enjoy them or that they've gotten use out of them. I don't even really care if you enjoy them necessarily, as long as you get something out of them, you learn something. That's the big thing, right? So again, like, subscribe, share, get it to anybody that needs 7.6 information or wants 7.6 information, people that are going through training, things like that. And yeah, on that, I'll see you on the next 2 videos, guys. See ya.